Okay, this is the sheet I gave y'all after the test Friday, and just follow along, fill in the notes, and you need to show it to me on Monday when I come back to school after the weekend. Next section is rational functions, and this is section 3.4 in our book, if you keep up with stuff like that. A rational function, these are examples of rational functions right here. It is basically just a function where your numerator and denominator, the top and the bottom, are both polynomials. And that is what a rational function is. And we're going to deal with finding all kinds of characteristics of rational functions. So the numerator and denominator are both polynomials, and these are a couple of examples. Finding characteristics of rational functions. We're going to find all of these things, domain, x-intercepts, y-intercepts, all that stuff. Before you find the characteristics, what you want to do first is factor both the numerator and the denominator, and if possible, cancel any factors. Cancel factors if possible. Sometimes nothing's going to cancel, but you always want to try to factor because it makes finding some of these things a lot easier. Finding domain, we've already done that. If you have a denominator, it cannot be 0, so domain's not going to change. Vertical asymptotes, after you factor and cancel, if you have anything on bottom that can equal 0, so if we have a factor left on bottom, any x-coordinates that make your denominator 0 is a vertical asymptote. And we'll do some examples of this in a minute. Boy, my writing is absolutely atrocious, but whatever. All right, anything that makes your denominator 0 that doesn't cancel is a vertical asymptote. Horizontal asymptotes depend on 3 rules, and you look at the degree in the numerator and the denominator. If your top degree is bigger than the bottom, then there is no horizontal asymptote. There's not one. It just doesn't exist. No horizontal asymptote. Okay, if the top degree is equal to the bottom degree, then you divide the leading coefficients. And if the bottom degree is bigger, or the way I wrote this is the top degree is smaller, but if the bottom degree is bigger, then your horizontal asymptote is y equals 0, which is also known as the x-axis. So your horizontal asymptote is y equals 0 if the bottom is bigger. If the top is bigger, there is no horizontal asymptote. And if the degrees are the same, then you'll divide the leading coefficients to get your horizontal asymptote. And your horizontal asymptote, it is a horizontal line, so they are always going to be in the form, if one exists, of y equals some number, because a horizontal asymptote is a horizontal line, and it needs to be written in that equation, that form. Vertical asymptotes are going to be in the form x equals some number, because they're vertical lines. A slant or an oblique asymptote, is if the top degree is 1 more than the bottom degree. So, for example, if the top degree is 3 and the bottom degree is 2, if the top is 1 more than the bottom, then you get the slant asymptote by dividing the bottom into the top. You can either do that with synthetic division. If you can't do synthetic division, you'll have to set it up with long division, which is kind of a pain. But that's how you do it. You divide the bottom into the top, and that gives you your slant or oblique asymptotes. I can't remember what our book calls it, but that's how you do it. So you divide the bottom into the top. Holes. You can have a hole in the graph, which just means that it looks like the graph looks normal, except there's just one little plug where it looks like you erased a piece of it. And holes happen if a factor cancels on top and bottom. So that very first step I told you about right here is you always want to factor and cancel factors if possible. If a factor does cancel, then that factor that you canceled gives you a hole, and it's whatever makes it 0. X-intercepts and y-intercepts are still the same. After canceling, you find the x-intercepts by, you set the equation equal to 0, but I'm going to make this a little bit easier. You set the numerator equal to 0. The denominator isn't going to matter. And that's after you cancel. So after cancel, find the x-intercepts by setting the numerator equal to 0. I should have said setting instead of set, but whatever. Find the y-intercepts, and this is the same as always. Plug 0 in for x. I'm plugging 0 in for x and solving for y. So x-intercepts and y-intercepts are pretty much the same, except for x-intercepts you only have to worry about the numerator. I think that was it for the characteristics. Okay, I want to do a couple of quick problems. First thing you're always going to want to do is factor and cancel if possible. Now, you don't want to completely scratch out your original problem. You want to still be able to see it because we can still use it. But we need to factor. My numerator will factor to x. Hang on. Factors of 8 that add up to 2 will be 4 and 2. And I need a positive 4 and a negative 2. So x plus 4, x minus 2. My denominator, I can factor a 2 out, which will give me x squared minus 16. Then my denominator continues factoring, so I have x plus 4, x minus 2 on top. The denominator is going to be 2, and then x squared minus 16 is the difference of squares. So x plus 4, x minus 4. And notice something cancels. I can cancel x plus 4, so my final equation is x minus 2 divided by 2 x minus 4. And you want to keep almost all of this. You don't want to scratch out or lose any of this work because we can come back and use whatever piece. We have 1, 2, 3, 4 equations. We're going to use all of those. So following along on that sheet, part A was done in the domain. Now the domain, you do want to use the original denominator. You don't want to use the one after you cancel. So I'm actually going to go back and to find my domain, I'm going to set my denominator equal to 0, and I'm actually going to use the denominator before I canceled. So after you factor, but before you cancel. So for my domain, I'm going to set 2 times x plus 4, x minus 4 equal to 0. And then we'll solve that equation. X equals negative 4 and positive 4. But that's what x cannot be because that makes my denominator 0. And I like interval notation, so my domain is going to be everything to the left of negative 4. And then everything between negative 4 and positive 4, and then everything after positive 4. So that's my domain. Next thing I think was vertical asymptotes. Let me go back. Next part is vertical asymptotes. So my vertical asymptotes, after you cancel, it's what makes your new denominator 0. So now, let's see, I don't need that anymore. So to find my vertical asymptotes, after I canceled, I was left with x minus 4. Whatever makes your denominator 0 after you cancel is a vertical asymptote. So I have a vertical asymptote at x equals 4. That's what makes my bottom 0 after I cancel. The next one I believe was horizontal asymptotes. And for horizontal asymptotes, which I'll abbreviate HA, this is when you look at the degree on the top and bottom, and I go back to the original unfactored one. My degree on top is 2, my degree on bottom is 2. So if the degrees are equal, I'm going to go back. If the degrees are equal, then we're going to divide the leading coefficients. So I'm going to go back to this problem. My leading coefficients are 1 and 2, so my horizontal asymptote is going to be y equals 1 divided by 2. That's my horizontal asymptote. If the degrees are equal, you divide the coefficients. Now part D, slant asymptotes, is only if your top degree is 1 more than the bottom. Since my degrees are equal, there is no slant asymptote. So I'll just make a little note, there is no slant asymptote. The next part was holes. Part E, I have a hole. Now remember, holes happen where factors cancel. Go back here. A hole is when a factor cancels, then whatever makes that 0. So the factor that I canceled was x plus 4. So my hole is going to be whatever makes x plus 4 0, and that's going to be at negative 4. So we actually have a hole at an x-coordinate of negative 4. And then the last part is the x-intercepts and y-intercepts. X-intercepts, we set the numerator equal to 0 and use the final numerator, x minus 2. So I'll do x minus 2 is equal to 0. I have an x-intercept of 2. And the y-intercept, the last part, you plug in 0 for x and you clean up for y. You can plug in anywhere. It doesn't matter which one you use. I'll just use this last one over here. So my y-intercept is going to be, I'll plug in 0 for x in this red equation, 0 minus 2 over 2 times 0 minus 4 That's going to be -2 over -8. My y-intercept is 1/4. So that's how we're going to find all the characteristics of our rational functions. Pretty much the only thing that's new is the asymptotes. We've done x-intercepts, y-intercepts, and domain. And holes is new. So the asymptotes and the holes is all that's new. The rest of it we've done before. The last problem, this one, same thing, going to factor first. Now my numerator isn't going to factor, so I will only factor the bottom. So 2x minus 3 stays as is. My bottom, this is going to be a little bit of a pain. It's going to be 2x and x. Then I think I'm going to need a 9 and a 1. 2x plus 1, x minus 9. That's how that's going to factor. Now this one, nothing cancels. So if nothing cancels, that means there are no holes for this one. There are no holes at all. So let's go ahead and start with the domain. Domain, you set your denominator equal to 0. So 2x plus 1, x minus 9, set that equal to 0. This is going to be -1/2 and 9. But that's what x cannot be. So my domain is actually going to be everything to the left of -1/2, everything between -1/2 and 9, and then everything after 9. Alright, so there's my domain. Next thing we did was asymptotes, vertical asymptotes. That's what makes your denominator equal to 0 after you cancel. Now nothing canceled, so my asymptotes are basically going to be like the same thing as my domain. I'm going to set my denominator equal to 0, 2x plus 1, x minus 9 is equal to 0, and actually we've already solved that, except this time my vertical asymptotes are x equals -1/2 and x equals 9, because that's what makes my bottom 0. So there's my vertical asymptotes. Horizontal asymptotes, I'll call this part C. Horizontal asymptotes, this is when you look at the degree. My degree on bottom is 2. My degree on top was 1. So my bottom degree is bigger. Let's go back and see what that means. Top degree bigger, top degree equal. Top degree smaller than bottom degree. If the bottom degree is bigger, this is what I'm saying down here on part C, your horizontal asymptote is y equals 0. So since my bottom degree is bigger, horizontal asymptote is y equals 0. There's really no work to show for that. That's probably the easiest part of all this. Slant asymptote only occurs when the top degree is 1 more than the bottom. So again, we have no slant asymptote this time, only when the top degree is 1 more than the bottom. E was holes, but we already know there are no holes because nothing canceled that. 2 S's for holes, that's okay. There are no holes either. So I think all we have left is x-intercepts and y-intercepts. X-intercepts, we will set the numerator equal to 0. 2x minus 3 equals 0. Add 3, divide by 2, and you get 3/2. So we have an x-intercept of 3/2. My y-intercept, this time I think it's going to be easier to use the original equation. Instead of plugging 0 in for all of my x's right here, I'm going to plug 0 into the original equation. So my y-intercept is going to be y equals 2 times 0 minus 3. So 0 minus 3 over 2 times 0 squared minus 17 times 0 minus 9, and that will clean up to 1/3. So there's my y-intercept. And that's all of the characteristics for this. We're going to add some more to this next week, but for now these are the basics, and this is kind of what I wanted y'all to get. Hopefully over the weekend, Monday when you come in, we'll hammer out some more details. What the heck? I haven't been recording the whole time? What's going on? I'm recording. Confused myself. All right. So that's it. This sheet you should have completed now because I just worked out the entire thing for you. Bring it in Monday for a homework grade, and we'll answer questions on it.